Hello. Hello, guys. Good evening. Welcome to the breakout session about customer metrics, machine learning, a machine learning approach. Uh, let me let me first present myself. Just a bit reminder: we are recording those sessions, so just for you to know. Sorry, like this. Okay. So first of all, let me briefly present myself. You see that we are two guys here. My name is José Antonio, and Jaime will present himself later. We are going to divide the presentation more or less into half. So I will take the first part, Jaime will take the second one. I'm software developer manager in Kindle, in the marketing team. I've been in the company for 5 years, and I started as an engineer. So I've been a manager for the last year. I was first an engineer, then a technical leader, and finally transitioned to a management position. And going to the point here, we are going to discuss about some interesting topic that we face on our daily life at Amazon. And our approach, we would like to have a humble approach with you and share with you how passionately we take goals and customer problems and try to solve them, which are the tools that we have to solve those problems, and which are the main dynamics that we follow to solve those problems. How do we go from a customer problem to a solution that is valid for them and provide value? And our approach is going to be close to ML, and Jaime will share with you an example, a specific example that we have been working on the team. Just giving you a couple of hints about who we are a little bit more. We are working on the same team. We are working on one of the team in the marketing on Kindle, and we share a common customer problem. So, and I will go through this customer problem later. So, just super quick over the agenda. The main idea is to, and the main takeaway for you is to understand how do we understand the customer problem and conceptualize them into solutions. How do we implement those solutions? What happened after we deliver what we implemented? And then we will have a case study. And for you, learning goals, things that we would love if you take with you. How do we approach those situations? Some specific techniques that we have, working backwards, A/B testing, AWS ML services, and I don't know, how passionate are we with the customer problem we are solving? This is something we would like to share. So what is that customer problem that we are solving about? So we are helping customers to acquire the healthy habit of reading, which is, I don't know, when we got to know this customer problem, we got passionate. It's super impactful for the society just to help people to read more. And now with all the social network, all the things going on, it's so important to come back and read. It's so important to, we think that by reading, we get better as human beings. So helping people to read is helping people to improve as human beings. So this is actually the problem that we are trying to solve. The question is, once you get this, you can say, okay, so what? What can I do? How can I solve this? Which are the tools? How can I want to code? I don't know. I'm an engineer. Give me a keyboard. I want to start coding a solution. So there is a lot of things happening before. And there is a lot of things that we need to prepare and we need to think about before we actually start coding. And there is a lot of things that happen afterwards. And we need to think about the results, and we need to iterate over the result to pivot and have a proper solution for our customers. So this slide basically summarizes what we are going to talk about. And I'm going to reiterate over the same idea. So we start with the customer problem, and we have an interesting phase to conceptualize the idea, to have something that we consider meaningful and impactful for our customers. Then, once we have this and we have a clear direction, we got a first iteration and start working on that. We implement that. And once we deliver that, we measure the results. We put it in production and measure the results. And we use specific techniques to measure those results. And finally, we review the results and iterate. We might discard the entire idea. We might transition to a new one. We might generate new ones. We might just iterate over the same one and improve it. There are multiple ways. And a word of advice here is how important is for us the data privacy, customer data privacy, every single project we run is supervised by data privacy. We don't execute this kind of projects that are actually using data intensively without considering this kind of privacy, just for you to know. So first of all, how do we conceptualize the problem? We have the customer problem and we want to have something to build. How do we do it? We use a technique called working backwards. And working backwards start always with the customer. So we use what we call VOCs, which is the voice of the customer, which is a way that we have to get the feedback that you guys provide on the web, that you guys provide on Kindle. And we know that feedback. And actually, we have a lot of different forums when we discuss about that specific feedback. And whenever we don't have that data, we go and pull the data from you. So we have UX research, quantitative UX research doing surveys, qualitative UX research doing customer interviews. We go through customer journeys. We create empathy maps. We have multiple tools, and with that information, we create a document, which is a short one. It's called PRFAQ. That document is usually composed by a press release. So we try to move in time to the moment we would be releasing the product and share this with the rest of the team. We have an FAQ section where we discuss about all the different things we would like to know more, all the different questions we would like to have, and then we have some visuals. We iterate over this process, and once we complete it, we get a kind of a compass. It's not a target, it's a moving target, it's a compass. We get a direction, and we are going to move on that direction. So once we have a direction, we start working on the next step. And what is the next step? The next step is implementing the first iteration. How do we do this? Once we have the what, once we have that document telling us what we want to do, we put it a multifunctional team. So usually it's the product manager, the one coming with that super interesting idea, transitioning something, conceptualize, crystallize into something that we want to implement. And we have a team that comes with marketing professionals, with UX designers, with applied scientists, with machine learning engineers, and with engineers. And we all get together and try to put the solution in place. And we organize a solution in place. We always work through a minimum viable product. Internally, we like to call it minimum lovable product, something that you will love. And we try to force ourselves, restrict ourselves to deliver that thing and do not have this kind of disease that's called featureitis, where you just create a lot of features and you don't know if the customer are going to love them. So we restrict ourselves to keep them the minimum. And then there is a super interesting motto in Amazon. It's still day one. It seems that we should behave like this is still the first day in the company. We usually think that this is still also an MVP. We are usually creating the next more minimum viable product, always. So once we have it implemented, there is one thing that you might be asking here. Yeah, come on, man, this is about ML. What happened with ML? Yeah, and you are right. So what is doing machine learning here? It depends on the team and it depends on the situation. But in our case, machine learning is critical, is key. Without machine learning, we can move forward on the process. Why? Because machine learning is helping us to understand what's going on, to understand why our readers are getting stalled or getting bored, not reading. So we apply this. And just giving a couple of hints about ML. What is happening right now in companies intense in data, like Amazon, it's like we have a lot of activity inside of our website, a lot of activity from our customers on reading books, purchasing books, selecting new ones, listening to books. We have a lot of information. So what happened is that with time, we started structuring that information in what we call data lakes. And we put it all together and we organize for consume it and for start understanding and looking for patterns inside those data lakes. And on top of that, what happened over the time is that we started having a specific data science roles. And those roles were like the ones owning that information and the patterns that we recognize on those data lakes. And the last thing that we do was giving them tools, giving them the best tools we can give them. And with those tools, we are able to move into production those ideas as soon as possible. Okay. So last thing here is that once we have that information, we try to put this ingrained in a customer-focused approach in our process. So when we decide that implementation, we move through that implementation with on the customer-focused approach using ML as one of the tools, as one of the assets that we follow. Later, you will have a specific example. But now, I would like just to dive deep a little bit on the tools. Yeah, we talk about tools. Which tools? So for tools, there is no, I would say that is obvious, right? So we love AWS. We use AWS for almost everything. But the question is that AWS is giving us all the tools that we need to build our solution. So just going into detail on some of them, we use Amazon SageMaker to put our models in production and to iterate over the model. Jaime will give you some details about Amazon SageMaker later on. We have Amazon Forecast, which is actually the forecasting tool that we are using internally in the company. And just for you to know, all those tools are available on AWS, so you can use it if you want. We have Amazon Lex and Amazon TextStract to deal with text extraction and data retrieval. We have Amazon Recognition, fraud detection to identify specific patterns. And also, you can see that on the bottom line, you see some purple icon. Those are data analytics specific tools. So we have Athena to query structured data and files. We have Data Lake Formation or IMR to play with that data and process that data. And we have Data Pipeline, Redshift, CloudSearch. We have tons of them. And actually, just for you to know, we have another set of tools. And we were discussing when we were presenting this because I wanted to zoom out and show you even more. Because there is a lot of tools. AWS guys are always delivering new and super interesting tools that we can use on our projects. So, okay, so we conceptualized the problem. We decided what to do. We implemented. We used the tool with the right things. Now what? Now success, right? No. Now is the beginning. Now is when we try to understand, is this the right thing? Were we right or wrong? We don't know. So we just try to take metrics. We try to pull what's happening. Are the users, are the customers using my button? Are they ignoring it? Why? If they are using my button, are they using my button for the right intent? Are they getting the value we want to provide? And once we have this, we iterate. We decide, okay, that was not the option, or we should do it in a different way. And how do we iterate and analyze the metrics? We do it with one specific thing. We iterate applying one technique that we call A/B testing. So let's say we have the traffic, all our customers using our features, and we divide the traffic into two halves, or depending on the feature, on different ways. One half is going to use what we call the control group. It's going to use the feature as it was before. The other half is going to use the feature as it is now. And we are going to compare. And we are going to measure the metrics. Are we providing the same value to both customers? Are they behaving in a different way? And we learn from this. And we try to know the long impact, the long-term impact that we want to provide on the customer. And we see we provide that long-term impact, we make the decision. Otherwise, we roll back. And I will say that this is, for now, the generic part. Remember, we started conceptualizing, then we use the tools, machine learning tools to implement a solution, and then we put it into practice and measure the results. Now, Jaime is going to tell you about the next step. What is the next thing to do, or a specific example that we do on our team? So, Jaime, whenever you want.
Yeah. So just give me a second to share my screen very quickly. Okay. Let me take over. All right. Can you see the slides, Jose, very quickly?
Yes.
Yeah? Okay, so we're good. All right. So hello, everyone. Thank you. First of all, thank you for joining. Apologies for that. So my kid is 2 years old. He was kind of like making a tantrum or something, so I had to see what was happening. So apologies for that. Hopefully it's going to be fine for the rest of the session. And yeah, so my name is Jaime Sanchez. I'm a senior software engineer. I've been working at Amazon for the last 5 years, same as Jose. We actually joined the company like with 2 weeks apart or something, but we've been only working together for the last year, right? So we're both part of this marketing team within Books, as Jose mentioned, and I want to tell you a little bit more about our team, what we do, etc., in just a couple of slides, okay? So what I want to do in this section now is like run a case study. So I want to discuss a project that we undertook on our team a while ago. It was a machine learning project, so hopefully it's something interesting. It's cool, and I hope you guys enjoy it. The whole idea is just to make all those concepts that José has discussed right now, make them a little bit more specific and more, let's say, tangible or real. Okay. So as I said, we both belong to a marketing team within Kindle. We have multiple disciplines on this team. So we have software engineers, we have marketing managers, product managers, applied scientists, and we all share the same mission, which is help our customers read more, right? So we are focused, especially focused or interested in customers who join Kindle for the very first time, because that is when we feel that we can have a bigger impact. When they're new to the platform, new to all the features, everything is fresh, right? That's when we can, let's say, like intervene with our marketing strategies and help them building this reading habit that we have as our goal, right? So this machine learning project that I'm going to discuss about, we started working on this a few months ago and worked through it for a good part of this year. It all started with the usual, let's say, like Amazon process. We wrote a press release, FAQ, we had a customer journey, but all these documents, they were trying to, come up with a fundamental question here, which was, can we predict how likely it is for a customer to build a reading habit? Like, is there a way for us to know the probability of someone reading on a daily basis? And this was like super interesting for us, because if we were able to pull up such a metric, such a prediction, right, then we could somehow try different things to see whether we could influence that probability, right, for the better, right? If we can somehow make something that moves this probability closer to 100%, right, then we will be helping our customers on reading more, right, like achieving our goal, let's say, right? So we started looking at this with a very naive perspective at the very beginning, right? So, okay, we have a lot of customer activity, as Jose mentioned before. Why don't we have someone looking at this data, analyzing it, and then giving us the probabilities, right? Like having a human looking at this, right? So, of course, that is very naive. It wouldn't work for many reasons, but the main one is it wouldn't scale, right? Like we have millions of customers on Kindle. It wouldn't be feasible for a single person to just take this task, right, and complete it, right? So the second approach was, okay, why don't we build a technical system, like something automated that can ingest all this data, right? And then maybe we can put some rules into this system, throw some heuristics, right? Some, let's say, if-else statements, right? And, like get the system to, throw the probability for us, right? Like spit it out. That would be problematic because, the data for this particular problem is quite complicated, right? Like there are many variables that come into play with regards to how likely it is for someone to read on a daily basis. And the relationship between this data, right? Like it's something that is not clear from just like looking at the data, right? So this started to look more and more like a machine learning related project. And, we decided, like why don't we build a machine learning model that helps us on making this prediction, right? Like giving us this probability of someone reading on a daily basis. And that's what we did. So we moved on into an implementation stage where we all work together, right? At the very beginning, it is true that the applied scientists on the team, they took some time, right, to, let's say, work on their own, experiment with the idea, tweaking the data, using or trying different features and training different types of models, iterating over those models. And then at the very end, after a couple of months or something, they were ready to share a trained model that was able to predict this probability accurately according to our, like, let's say, internal quality standards, right? So we got to a point where, we had the model, it was already trained. And the next step would be to, run this model in production and get the probabilities for all of our customers, right? So that is the part where us, the software engineers, could help the most, right? So taking the model and building the necessary infrastructure to run this reliable, at scale, etc. Right? We had two main requirements. One was this model needs to be run every day, right? And the other one was the model needs to be run for all customers that are new to Kindle worldwide, right? That is in the millions, right? So we're talking millions of customers every day. So we started looking for different tools, different frameworks that could help us on running this model in production, right? We, of course, looked at all the tools that Jose has mentioned before that are available on AWS. But we settled with AWS SageMaker, okay? SageMaker is meant to be like the one-stop solution for machine learning within AWS, right? And you don't need to look at all of this right now on this slide. There is a lot of details here, but essentially what you need to get out of this is that SageMaker gives you, it has many features for many different aspects of any machine learning project that you might be undertaking, right? So whether you're worried about, like gathering data sets and labeling them, or you're worrying about training models, like there are features on SageMaker to support all those things. In our case, because our model was already trained, what we really cared about was finding a good, let's say, runtime for the model to put it in production, right? And in terms of runtimes, SageMaker offers you two cool features, right? So one is what it's called real-time model inferences. That is meant to be used when you have a use case where you have a model that you need to be running 24/7, let's say, right? It has to be available 24/7. You want to get inferences out of your model very quickly, right? Like with milliseconds of latency, right? And think of it as like, you have a model and you want to call it via an API or something, right? That's what you would use, right? Then there is this other runtime that is called batch transform jobs, which is meant for batch use case, like the one that we have. So essentially, when you have a model, but you don't need it to be available 24/7, you just need to like run it a few times, like maybe once a week, right? You don't really care that the model takes too long to give you the predictions, right? Like it can take hours, that's fine for your use case. And maybe, yeah, so, oh yeah, and what is important here is like, what you really care is maybe, like I don't care how long it takes, but please run this for millions of entries, right? Like give me millions or thousands of inferences here, right? So that batch runtime is what we used. And I want to show you a little bit more of details of how this works internally, right? So when you want to use the batch transform jobs within SageMaker to run like a batch transformation out of your model, you create a job and you specify three things, essentially. So you first specify a location within S3 to where your features are, right? For all of the scores or all of the predictions that you want to get out of your model, right? Then you provide an S3 location where you want to store the output of your model to do something with it later on, right? And then finally, you need to provide your model to SageMaker to be able to run it, right? And the way you provide it, I think it's pretty cool, right? Like SageMaker establishes like a contract, right? So what it expects is for you to provide a Docker container that is kind of like wrapping your model, right? And that Docker container must have certain properties. So it must have a web server running inside of it and listening in port 8080. And it should be able to handle these two entry points. So slash invocations is what SageMaker will call to get inferences out of your model, right? That is, let's say, where your business code lives, let's say. And then slash ping is just a health check, right? That is going to allow SageMaker to identify whether a specific instance of your Docker image, right, is healthy or not, whether it should kill it and spin up another one, etc. That's how SageMaker will make those calls, right? So once you specify all these things, right, SageMaker takes care of orchestrating everything, right? So essentially, it looks at how many entries you're going to need to run through your model by looking at the S3 location for the input, right? And it will make a decision on, how many of these Docker images I need to run, how many instances of your model are going to be running parallel, right? And yeah, that's essentially what it does. One more thing that is interesting here is how do you deploy the model artifacts themselves, right? So just for all of you who are not like familiar with the ML subject, what I mean by model artifact is when you train a model, what you end up with normally is like a binary file, let's say. That binary file is, like the model encoded, right? And then you should load that binary file in runtime, right? Just to call it and get the inferences out, right? So those binary files, if you're working on Python, for example, those would be like pickle files, something like that, right? Those binary files can get pretty huge. So sometimes it's not feasible or it's difficult for you to wrap the model artifacts within the Docker image itself, right? So SageMaker gives you this feature where you can deploy the model artifacts to S3, where there's no limit in size, nothing like that, right? And it will create like a tunnel, let's say, between your Docker image and S3. So your Docker image can access the model artifacts as if they were deployed locally within the Docker container, okay? So this batch transform thing is what we used, is the core piece of where we run our model, but it wasn't the only thing going on, right? So I want to give you like a more bigger picture of things, right? So in our particular case, the features for our model, like the interesting data for our model, it lived on the Amazon internal catalog, right? So all of the customer activity that we have lives on this catalog where it's protected, it's secure, like we enforce all of this data privacy, etc. But our model needed to get those to read the features from AWS S3. So we needed to bridge that gap, right? Like we needed to move the features from the internal catalog into S3. And for that, we used AWS Glue, which is essentially like a kind of like a map reduce technology within AWS. You point it to an input data, right? Or an input data set. You tell it, okay, load this thing, transform it in this way, and then dump the results in some other place, right? So we use that Glue job to just read from the catalog, pick up our features, and then dump them on S3, right? On the input folder, let's say. And that's it, right? So once we had AWS Glue and SageMaker, the only thing that was missing was a way to orchestrate this, right? Remember, we need to run this daily, right, for all customers. So the way we did the orchestration was by using AWS Step Functions, which is, again, another service on AWS that allows you to model complex workflows that require different AWS services to be coordinated in some way, right? So we use step functions for this. We modeled our workflow. It was pretty simple, just 2 steps. First, run Glue to bring the features into S3, and second, run SageMaker to, score all of this through our model, right? And then write the output back to S3 and our internal catalog. Once we had this in place, the only piece that was missing was, the running daily kind of thing, and that is pretty simple, right? So we essentially added like a scheduler to our workflow on step functions, right? That will kick off every day at, 9 a.m. or something like that, okay? So that is more or less the architecture that we followed. And I want to tell you a little bit more about what happened next, okay? So with this, once we were done with the technology piece, let's say, we had the model running in production and giving us probabilities of how likely it is for customers to read on a daily basis, right? And we were storing all of those probabilities back into the internal catalog, right? And the problem that we had was that the internal catalog is not like super friendly for humans, right? Like if you need to look at the data, it's not like meant that's not its purpose, right? It's quite difficult. So we decided, why don't we create a dashboard that we can, look at it, analyze it, right, among the team and see what cool insights are we getting out of this model, right? So we decided to use AWS QuickSight to create this dashboard. Again, another AWS service that allows you to, bring data from somewhere, right, and then build visual dashboards very easily, right? So we built a dashboard with this, with the output of the model. And we started looking at this, right? So we were able to see for each of the customers what was the probability of becoming someone who reads on a daily basis. But more importantly, because we were running the model daily, right? We were able to see how that probability evolves over time, right? Whether it would go up, it would go down, it would keep going up, et cetera, right? So we were able to spot trends, right? And just by sheer force of looking and analyzing this data, we started identifying patterns, let's say, about those trends, right? Meaning that there were different things where this probability could evolve, right? But there were a limited, let's say, number of those trends, right? So we have those patterns, right? And we use those patterns to make an internal classification for customers based on how the probability was evolving, right? So we got all of those insights, right? We discovered there were trends, we discovered there were patterns, we discovered there were different types of customers based on this probability and how it evolved over time, right? But then what? What do you do with that information? So what we decided to do is, we're a marketing team, right? We have this capability of sending emails and different push notifications, etc., to our customers, right? Why don't we try to send different stuff to different kinds of customers based on this trend for the probability, and see what happens. Maybe we can have an influence on how this probability evolves over time, right? Some of the things that we might try might work, right? Meaning something that works for us was something that maybe we send an email, and then what happens is there is an uplift on the probability, right? It goes up. Some things might not work, right? Maybe there's no effect whatsoever on how this probability evolves. Or maybe there is even a detrimental effect, the probability might go down, right? So we decided to run an experiment. Let's just try different content for different customers, send different types of emails with different stuff, right? And let's see what happens, right? So we ran this experiment for a while, right? And then we analyze the data. I cannot give you obviously the details of what happened, right? That's kind of like a business secret. But what you need to know is we got results. And we saw what we were expecting, right? Some things worked, some things didn't, right? And then how did we use this information, right? The way we use this at Amazon, not only on this project, but in general, the way we use these results at Amazon is it helps us prioritize what to do next, right? So from the things that we tried that didn't work, right? we decided to discard them quickly, right? So no more, let's say, entries for that on our backlog, right? For next year, like that doesn't work. Customers don't like that. Let's just park it, right? And for the things that did work, indeed, right? The things that essentially move the probability up, right? What we want to do is like keep iterating, right? So we design new experiments, right? That maybe tweak a few things, try to optimize. Maybe we add some features on top of that and see how they work, etc. So we repeat this process over and over and again, right? So what's important here is what we're optimizing for is, like for all those things that have an impact, moving the probability up, which means customers would reach a state of like reading daily quicker, right? And that will help us accomplishing our goals of like, helping customers read more, read daily, etc. And that's it. That's all we had for today.
Yeah, let's go. We have some questions, Jaime, on the chat. Let's go with them. I'm jumping I'm jumping to the first one. I think that there are someone on my side, someone on your side. I'm going to start with the ones on my side, and let's go one by one. Okay. So we have this one. How much time from José, which is not a common name in Spanish? Sorry, like mine. How much time a team has or is allowed to come up with a good idea until a project is closed? So I would say that it depends, because usually it's not about giving time to the team to implement the idea. The fact that we go in short iteration makes super simple to just provide some results in 1 month or a couple of months and start iterating over those results instead of just waiting for a year for a team to come up with a solution. We have multiple ways of disclosing or finding ideas. Once a year, we get together and we run a process that allows us to disclose new ideas and to contribute to them. And it's a process where the entire company is involved. Regardless of the play, the entire company is involved on thinking long-term, thinking big, and identifying things to do. Then we have other ways. We have hackathons where we usually try to experiment. We have other different framework where we can just show ideas. And I've seen a lot of people just pursuing a specific idea and implementing. But at the same time, we're a data-driven company. So nobody is like investing on dreams. You need to prove. You need to prove with data what you want to do, and you need to prove that it's going to be impactful. And then the company decide to move on that direction or not. So it's not about time, it's about excitement. It's about convincing people with data-driven decisions. So let's go to the next one. What is exactly a peer FAQ? So a peer FAQ is a document where we actually use to convince internally how to move. It's like the star on the horizon. It's the North Star. The peer FAQ is telling how it's going to be when it's done, and it's starting on the customer, always starting from on the end, on how the customer is going to perceive what we are implementing. And that's why peer for press release, super important. FAQ, because usually we come up with millions of questions, and we just prioritize and put the most important ones there. And the visuals are also important here. Okay, Jaime, this is one for you, and I like that one. What model exactly did you use?
Yeah, I'm sorry, Cesar, but I cannot disclose those details. As you can imagine, this is a very sensitive thing, meaning it's kind of like business. It's treated like business secrets internally. So I would love to tell you, right, but I cannot. I'm really sorry for that.
Yeah, Cesar went to the point. I think it's a good question. So yeah,
I know.
Show me the model. Show me the model. What the hell?
I know.
Yeah.
Yeah.
Okay, and now we have one from Jaime Van Hool. How did you get your model generalized?
To be honest, I'm not sure I understand this question fully. Okay, and it might be because there is some knowledge gap here. So I want to give you just a quick detail of how we actually work here, right? So as I said before, we have. Oh, I'm not on mute. Sorry. Okay, I thought I was on mute. So we had a team with like multiple disciplines, right? And we have several of them, but one is like the software engineer, right? And the other part is like the applied scientist, right? So for this particular project, and this is not how it works at Amazon, like generally, but for this particular project, we decided to split responsibilities, right? So the applied scientists were, like the people who worked on the model itself, right? And we decided to treat this as a black box, as a black box as software engineers, right? So I know some details, I know more or less about the process of how this model got developed and, what features were used, etc., right? But I don't know exactly like the whole subject area of like the data science, let's say, right? Where we helped a lot was more on the scaling and automation of running this thing daily for millions of customers, right? That is our area of expertise, let's say. On that one, I have a lot of details, right? But unfortunately, not on the data science and the model development itself. So, yeah, I don't know exactly what this question means, and I apologize for that. Sorry.
Yeah, then Cesar Goodman. No, regarding SageMaker, Carlos Cuega is saying that regarding SageMaker, do you use its features or do you go low level to design a model?
So the way I understand this question is like whether we use, I don't know, whether we use the features from SageMaker exactly as they are, or we do something differently because we are a team within Amazon, within the company. In our case, we're just using everything by the book, right? So meaning the documentation that we use to, like deploy our model on SageMaker, etc., is the public-facing one, right? Like the same as any other AWS user or AWS customer uses, right? So the features that we use from SageMaker are available to absolutely everyone. Nothing fancy, nothing internal, nothing low level that we had to do differently just because we were an Amazon team, right?
Yeah, we use AWS as customers. Then we have would you have another one? Yeah, Carlos SageMaker is like Jupyter. Yeah, is I would say that on asteroids. So it's Jupyter plus 1,000 more things that you can use. But yes.
Yeah.
How did you define?
Can I say? Sorry, let me give some more detail here. So what SageMaker is trying to do, at least from my perspective, is trying to be like the one-stop solution for ML, right? So all of the tools that are typically used by data scientists and other engineers working on ML, right? They try to put an equivalent feature within SageMaker, right? So one thing that you can do on SageMaker is you can have notebooks like the Jupyter notebooks, right? But it's not restrained to that, right? Like there are way like there are other things that are interesting, right? Like for example, they have runtimes for your models. They allow you to train your models there. They allow you to gather data and like label it easily, etc. So it's not like SageMaker is like Jupyter. Let's say like SageMaker has its own Jupyter inside, but it has other things as well. Okay.
Okay, do you have this one? How did you define labels and time spans for them? I think that one is for you, Jaime.
I know, but yeah, it's unfortunately a bit difficult of what Martin is referring to.
It's difficult to reply that one.
Yeah. I don't know if you refer to, like how did we classify our customers when we had the data out of the model? But if it's that, right, like again, that is something where our data scientists worked very hard. They tried on like different cuts, let's say different cuts of the data, right? And they picked like, let's say the sweet spot that was giving us, the cleanest trends or something. I don't know how to define it better.
Yeah. So then we have another one that, we mentioned several, I mentioned several AWS ML related services, but we don't use them on every customer problem. We use them depending on what we need to do. So sometimes we use SageMaker, sometimes we use other ones. So on that particular example, we want to go through SageMaker. Okay, how technical do you go with SageMaker? I think that we already answered that one. SageMaker is way more, that one. Okay. A/B testing. Yeah, for A/B testing, do you want to take it, Jaime?
No, you can go, Jose. I feel like I've answered a bunch of them already.
For A/B testing, we have a specific tooling, a specific internal tooling helping us to do this super quick. And we are so used to do it that we have a specific name that actually I can disclose. That is like the tool. It's like Colacao. We use that word for everything. And even we use that word for release. We never release directly. We release through that tool, which is A/B testing over our customers. I just wonder if they were SageMaker libraries, which is a kind of middle-level library, or they go lower like TensorFlow. Jaime?
Yeah, sorry, definitely you can. So there is a feature on SageMaker that allows you to train models, right? So essentially what you do is you define some code in Python, for example, let's say, that can use any library you want, like TensorFlow, right? And then you run a job where you specify, this is the code to train my model. I want, I don't know, 6 instances, six servers to run this and train my model in parallel, maybe if possible. And then SageMaker takes care of that for you. So all of the usual, let's say, the normal ecosystem of libraries for ML, they're available on SageMaker, 100%.
Yeah, we have like 30 seconds, so I'm afraid we're not gonna have time to go over all the questions, and we will do our best. So did you structure your models as an API, Jaime?
So on this case, we didn't need like an API, meaning we didn't need to expose our model to an external service. All we wanted was just the data out of it. So the only API that we put in place was the one that SageMaker enforces, which is, as I mentioned before, right? You have the Docker image with a web server, and you need like a / invocations kind of entry point. So that is the only thing that we did in this case.
Yeah, then we have another one about collaborative engineering creative process. We have market tools to do this. We don't have nothing. We have an internal tool that is super similar to Jira, and we have communication tools that you might find also on the market. Typical like Confluence, communication wikis, and then we use Slack to as a chat. I think that is public. Was public a short ago, and you use a lot of Chime, whiteboarding. Is a regular thing. What is the main metrics that you see that you used to know when to update the beam from the model?
Yeah, so there is a feature on SageMaker as well that is called SageMaker Model Monitor. Essentially, what that does is it kind of like keeps track of your model, right? So you provide let's say this is all public as well, right? So you provide like a baseline of the distribution of your input features and the distribution of your output for the model, right? Like here's how these things should behave. Here's the probabilities that the distribution of probabilities that they should follow, right? And then Model Monitor, what it does is every time your model runs, it keeps, a snapshot of what is it that goes in and goes out, right? And it automatically detects, let's say, like drifts on what you were expecting as a baseline, right? So one of the challenges when you deploy a model is, over time, what happens is the distribution of the values of the inputs and outputs, they start changing because customers change behavior, right? So when that happens, right, it's good to have a system like Model Monitor in place to detect those changes, right? And triggers you an alarm of some sort so you can adapt to them, right? So we have a system like that in prod, and when that happens, like we go back to, let's say, to the lab, right, and adjust the model a little bit to, cater for those changes. That's how I put it.
Jaime, we need to finish.
Okay.
We need to finish here. So sorry for not replying all the questions, and thank you for all of them.
Sure. Thank you everyone for joining. I think if you guys want, you can join the next session by going to this specific link. I really hope you enjoy the rest of the career fair, and thank you for joining. It's been a pleasure having you here.
Thank you. Bye.